Assalamualaikum warahmatullahi wabarakatuh. This video is going to cover on the next topic on process models. So the objectives of this lecture is that you should be able to explain what is a software process model, list and elaborate types of software process models, and finally explain the characteristics of the process models. So the topics that will be covered, the first one is introduction, then we'll go to the prescriptive models, and then we're going to look at specialized process models. Then we're going to look into unified process, and finally personal and team process models. So as an introduction, what is actually a process model? In the previous lecture, we have seen the process framework, and it's actually a continuation of that particular topic. So a process model provides a roadmap for software engineering work. That means it defines all the flow of all activities, actions and tasks, and the degree of iteration, the work products, and also the work organization. That means this process model is actually like a guideline for any software development activities. So who actually choose a process model? So normally managers and software engineers will be discussing on which process model that they are going to adopt in a specific project. Why is it important to have a process model? Because having a process model shows that you have stability, you are in control of your development tasks, and also you know how to organize a software development activity. So what does the process model provide? Okay, other than that, it also provides us with the steps on how to execute all these software development work systematically. What is the work product? Okay, it's a description of activities and tasks defined by the process. Let's say you're talking about testing. Okay, what are you going to do in testing? What kind of activities that you're gonna plan, design, and execute in testing? In the end, what are you going to produce after finishing the testing activity? So that is an example for work product for testing. How do I ensure that I have done it right? Okay, so in order for us to know whether we are on the right track or we have done it right, we have to have software process assessment mechanism like quality assurance activities to make sure that we are on the right track. So a generic process model is providing the process framework, and inside the process framework we can have umbrella activities, which I mentioned already in the previous lecture, and the umbrella activities can cover more than one framework activity. So in this framework activity, let's say we have framework activity 1. Inside it we have the task sets, which includes the work task, work product, quality assurance point, milestone. Any deliverables will be defined here, and we can have a series of software engineering actions. Okay, this is for one framework of activity. Let's say we are talking about requirements, then we have for design and so on. So these two framework activities can have an umbrella activity which covers both of these framework activities. So a process flow. A process model contains the steps. Okay, if you go back to the previous slides, it mentioned about the steps, right? So if you look at this process flow, what element or which element actually demonstrate the flow? Is it the rectangle here, or is it the arrows here? So yes, you are true, it's actually the arrows that determines the flow. What you can say about this arrow? Think about it. What characteristics that you can say about this process flow? Okay, it's sequential, right? That means it must be executed one after another. That means in this figure, you can see that first you have to start with communication, then you move on to planning, you move on to modeling, you move on to construction, and you move on to deployment, right? And in the end, you have the outcome. So these arrows actually determine the process flow. Okay, what can you observe from this process flow? That means they must be sequential. Okay, that means in order for you to do planning, you have to finish communication first, and you cannot go back to the previous step. So it must be in some order, and the order is, we call it as sequential. Okay, what does the arrows represent? Now these arrows represent the ordering of the process flow. What are the characteristics of this process flow model? Okay, you can see that one of it is that you must finish one process before you move on to the next one, right? Okay, so let's say if you have any error, okay, let's say when you do modeling, you find out that you have an error. Okay, so according to this process flow, we don't go back and fix it. We move on to the next phase and proceed. Then you go and repeat the process from the beginning and get feedback from the stakeholder, which part that is wrong and so on, and you plan again and you include all the changes. Okay, so those are some of the weaknesses. But what do you think about the strength? What is the strength of this process flow? Surely it must be relevant to some context, right? Okay, which context that you think is mostly suitable to use this process flow? Okay, so we call this as linear or sequential process flow. Okay, so now what can you observe from this process flow? Now you can see that the arrows, in addition to the arrows that are linear or sequential, you can see that some arrows are going back to the previous process. Okay, or we call it as iterate. Okay, or iterate back to the previous process, or iterate to the same process. For example, here we go to communication, from communication to planning. Then if you need to fix anything, you go back and iterate, yeah, until it's okay. Then you move on to the modeling. Maybe in the modeling you have to iterate the process many times. Then you move on to construction and so on. So the process flow now, not only linear, is actually combination of linear and iteration. Okay, but in here we want to focus more on the iteration. Okay, so what are the characteristics of this process model? Okay, it allows you to go back and do addition to some phases. Okay, so you don't have to wait until the end, then only you fix the error like in the linear or sequential process model. Okay, that is one of the strengths of the model. So in here we want to focus more on the iterative part. Okay, next we have the next process flow. Okay, what can you observe from this process flow? Which one represent the order or the sequence? Okay, so you can see this is an arrow, and you can also have this arrow as an input and this arrow as an output from the complete model. Okay, so first you get the input and you perform the communication phase, then you move on to the planning phase, modeling, construction, deployment. Now the difference is now if you have anything to fix, I mean the next version for example, so you go and further iterate the next cycle. Okay, so you go and communicate again and plan, model, and build construction. Okay, so a significant property of the process flow is that it has this increment release. That means in the beginning it is planned to produce small parts of the system. It's not as a complete system. Like you can see in the linear or in the iteration, most of the projects are looked as a whole rather than as increments. So in this process flow, you want to produce small scale of the system, okay, or you can call it as increment. Okay, so what are the strengths of this process flow? That you can systematically plan your outcomes into smaller partitions so that it's easier for you to organize your products. Okay, or you can think about it as features. Maybe a few features you implement first, maybe based on stakeholders. Okay, if you have many stakeholders, so you focus on one type of stakeholder first, then you move on to the next stakeholder. So that can also be considered as increment. But in general, we say that we break the big project into smaller increments so that it's easier for us to manage the project. Okay. So we call this as evolutionary process model. Okay, we keep evolutions of the system, so we call it evolutionary process flow. So the next one, now what is different now? You can see that now it is arranged in some order, right? The processes, okay, they are not in sequence, they are not in iterations, but they have some ordering. Okay, so in here perhaps you start off with communication, then you move on to planning. But while you're doing planning, you start a bit with modeling, and while you have not even finished with the modeling, you focus on construction as well, and these are done in parallel. Okay, so the arrow here represent ordering in terms of parallel. Okay, so the characteristics are that some of the activities are done in parallel with differences in terms of effort. Okay, so what are the strengths? Okay, perhaps you can organize your team members to start first with the resources that you have, and while you are moving on to the timeline of your project, okay, your team members can work at parallel. They don't have to wait until a team has finished their task, then only the other team will work on the outcome. Okay, now you can have them to work at parallel. Okay, so in terms of weaknesses, perhaps the organization of the work tasks will become much more complex. Okay, because you need to make sure they are not doing things in a wrong way. So this is to represent parallel process flow. So this is a summary to show all the process flows that we have seen just now. So the first one is linear or sequential. You can see that the arrows represented in a linear manner. Okay, that means in order for you to do one phase, you have to finish the previous phase, and you cannot go back to the previous process. Okay, the second one is iterative, so we focus more on return back to previous processes, or it can iterate back to the same process. The third one is evolutionary. The main idea is to have a series of iterations, and each iteration you have an increment being produced. Okay, So these two focus more on a system as a whole. This one is more specific to a part of the system. And the last one is parallel, which means that some of the activities are done at the same time, perhaps with different emphasis. Okay, but in the existing process flows of any process model available in the industry may also be combination of a few of this. Okay, so later on in the end of the slides, you will be required to find a process model and find out which characteristics of process flow that it has. So now we move on to prescriptive, or sometimes people call it as traditional models. Okay, so prescriptive process models provide structure and order in terms of software development. Okay, so activities and tasks occur sequentially with defined guidelines for progress. That means it will describe framework activities, what are the actions, what are the tasks, what are the work products, how do you know the quality of the task that you have done, and change control mechanism if there is anything happen, how are you going to counter measure the issues. So prescriptive model meaning that they will show you the processes and their interrelated relationship between the process elements. For example, here the analysis and design, you can see that the transition from analysis to design, but there is no transition back. Okay, so in this process flow, you are moving from here to here in a circle. So each model attempts to accommodate the generic activities in software engineering, which are the 5 framework activities, applies different emphasis to these activities, and defines a process flow in a different manner. So the prescriptive model will have its own variances.